Hello everyone and welcome to the next video in the series. This is a problem solving skills video on general percent problems. Now I am hoping that you have watched the two videos that come before this. One of them is on working out a fraction, decimal fraction or percent of a value, and the second one is on working with money problems. What you'll find in this video is that the kinds of percent problems that we work on fall into one of four categories, and these four categories are the same as the four that we saw with money problems. So every problem that we work on here will be either similar to an amount of discount problem, a sale price problem, an amount of tax problem, or a grand total problem. And if you've understood money problems, that makes it much easier to understand this video. I would also say that I will be following a very particular approach in the teaching of the subject matter or this topic in this video. Although there are multiple approaches to coming up with the equation that models the problems that we work on, I would like to follow one where you come up with a key statement, a key sentence that allows you to write the equation. I find that this approach makes you most functional because quite often you don't have pen and paper to use these other approaches, some of which require that you make a table and put your percentages in that table. Others require that you make a tree kind of a diagram. Now don't get me wrong, it's good to know all these different approaches, but I think the most important one is the one that sort of teaches you how to come up with that key statement, because when you're on your feet and you're trying to think, you may not have pen and paper and you may not be able to or have time to draw all these tables and tree diagrams just to work out one problem. Right, so you'll find that there are no diagrams today on the right side. Okay, so let's take a look at problem number one. We'll start with problems that are similar to amount of discount, problems that require that you find the amount of discount. Problem 1 says the population of a town decreased by 5.7% over the past 10 years. Calculate the amount of decrease if the population was 142,000 10 years ago. And if you think about this problem, you notice that it is similar to an amount of discount problem. In an amount of discount problem, we have a decrease in price, and this is similar to that in the sense that the population decreases. And in an amount of discount problem, we would like to find the amount of discount, of course, and here we want to find the amount of decrease in the population. And so the key sentence that tells us how to write the equation that goes with this problem is to be able to argue that based on what we see in this problem, the amount of decrease is 5.7% of the initial population. And here you have it. So amount of decrease is 5.7% of the initial population. And if we can sort of come up with this key sentence, then the algebraic solution is very easy to write. With A being amount of decrease in population, unit 1, A becomes equal to 5.7% of the initial population. So the amount of decrease in population, I get that from here, is 5.7% of 142,000. Now I write this in orange or faded color because normally we prefer to write our equations with decimals in place of percentages. So normally the percentage is converted to a decimal and then put into an equation. And in this case, if I convert 5.7% to a decimal, percent of course means divide by 100, which means decimal point moves back over 2 digits. I get 0.057. So the equation that I would write would be A equals 0.057, 5.7% of 142,000. Working this out, we'll find that it comes to 8,094. So the population decreased by 8,094 people. Now, if this was a money problem, it would have been something similar to this. Let's say that you are very, very rich and you want to buy this super nice car, which is priced at $142,000. And it's on sale at 5.7% off. And you want to find the amount of discount. In that case, you would find 5.7% of the price of the car. And here we also have a decrease in this problem as well. There is a decrease in the population by 5.7%, and just as the amount of discount can be computed by finding 5.7% of the initial price, here we find the amount of decrease in the population by finding 5.7% of the initial population. Okay, let's move on to problem number 2 now. And this problem says, in a sample of 420 frogs, 18.5% have red eyes. How many frogs in the sample have red eyes? And the key statement that goes with this problem is that the number of red-eyed frogs is 18.5% of the total number of frogs. And for an algebraic solution, now this time I will be using decimals to begin with n being the number of red-eyed frogs in the sample unit 1. N becomes equal to 18.5%, but converted to a decimal. 18.5% of the total number of frogs. And it comes to 78. So there are 78 red-eyed frogs in the sample. Problem 3. I would like to save 15% of my income every year. How much should I save this year if I make $72,000 per year? The key sentence then is that the amount of savings is equal to 15% of my annual income. It actually is pretty explicit here, 15% of my income. That would be 15% of 72,000. And for an algebraic solution with A representing amount of money I should save this year in dollars, the amount of money I should save becomes equal to 15% as a decimal, 0.15, 15% of my income, which is $72,000 per year. And so I should save $10,800. Okay, so these were 3 problems where which were similar to amount of discount problems. Now we move on to the second category of problems, and these are the ones that are similar to sale price problems. Problem number 4. The population of a town decreased by 5.7% over the past 10 years. What is the population today? If the population was 142,000 10 years ago. Now you notice that the difference between this and problem number 1 was that with problem number 1 we wanted to find the amount of increase, but now we want to find the total after, which is amount of decrease, my apologies. But now we want to find what's left over after the decrease, so we want the new population. And if 5.7% represents the amount of decrease, is the percentage that goes with the amount of decrease, then 100% minus it represents the percentage that goes with the population, what's left over. The key statement is population today is 94.3% of the population 10 years ago. 94.3% comes from 100% minus 5.7%. So what's left over after you cut off 5.7% will be 94.3%. And so population today is 94.3% of the population 10 years ago. For an algebraic solution with n being the population today, unit 1, n becomes equal to 100% minus 5.7%, so we sort of explained where 94.3% comes from, and then of the initial population, or population 10 years ago. And converting these to decimals gives us n equals 1 in place of 100% and 0.057 in place of 5.7%. And this comes to 94.3% of the population 10 years ago. So 133,906, which implies that the population today is 133,906. Problem 5. In a sample of 420 frogs, 18.5% have red eyes. How many frogs in the sample do not have red eyes? So the difference between this problem and problem number 2 is that here we are talking about what's left over after we remove the number of red-eyed frogs. With problem number 2, we wanted the number of red-eyed frogs, and here we want the number of non-red-eyed frogs. the key statement is number of non-red-eyed frogs is 81.5% of the total number of frogs. Now 81.5% comes from 100% minus 18.5%. If 18.5% of the frogs have red eyes, then 100% minus 18.5% of them do not have red eyes. That's what I'm looking for. Okay, so for an algebraic solution with n representing the number of non-red-eyed frogs in the sample, unit 1, n becomes equal to 1, that's 100%, minus 18.5% of the total number of frogs. So that's 81.5% of the total number of frogs, which comes to 342. And therefore there are 342 non-red-eyed frogs in the sample. Okay, let's put a bit of space there. All right. Okay, next problem. I would like to save 15% of my income every year. How much will I have left after my savings this year if I make $72,000 per year? Now the difference between this problem and problem number 3 is that in problem number 3 I wanted to find the amount of money I should save, but now I want to figure out how much I will have left after those savings. So again, it's similar to a sale price problem where you cut off the amount of discount, and here we have you cut off the amount of discount from the price, and here we have to cut off the amount of savings from my income. Okay, so the key sentence is amount left this year after savings is 85% of my annual income. So if I'm saving 15% of my annual income, then I will be left with 100% minus 15%, or 85% of my income. For an algebraic solution with A being the amount of money that's left this year after savings in dollars, A becomes equal to 100% minus 15% of my income, so 85% of my income, and that comes to $61,200. So after savings this year I will have $61,200 left. Okay, now if I was going to work this out on the calculator, then I would write down, if I wanted to work this out on the calculator, then I would start with the initial, with the amount of money that I make every year. So with my income, I would enter that first. So let me bring in the calculator. Okay, so I would enter 72,000. And if I'm looking for the amount of money that I should save, then I would multiply this by 0.15, 15%. I'm trying to find 15% of it, which comes to 10,800. However, if I wanted to find out how much I will be left with, 72,000, you can enter the income first, and then you multiply this by 0.85, which is 85% of it, and that tells you that you need that you will be left with $61,200. Okay, so these problems were similar to sale price problems. Now we talk about problems that are similar to amount of tax problems. So again, we're trying to find the size of a piece, but the piece will be added on to the total, to the initial amount later to find the total. Question 7, problem 7 is the population of a town increased by 5.7% over the past 10 years. Now with the earlier problems, we had a decrease, but now we have an increase of 5.7%. Calculate the amount of increase if the population was 142,000 10 years ago. The key statement is amount of increase is 5.7% of the initial population. And with A being amount of increase in population unit 1, A becomes equal to 5.7% of the initial population. And so 0.057, which is 5.7% of 142,000. And that comes to 8,094. So the population increased by 8,094 people. Okay, next problem. Price of goods increased by 2.4% this year. How much more will you have to pay for a laptop that cost $750.99 last year? So here the key sentence is that the amount of increase, or the increase in price, that's similar to amount of tax, is 2.4% of the price last year. And for an algebraic solution, with A being amount of increase in price in dollars, A becomes equal to 2.4% of the price last year. So A is equal to, now in decimal form, 2.4% of the price of the laptop last year. And that comes to $18.02. So I will have to pay $18.02 more compared to the price of the laptop last year. Number 9, elementary school enrollment increased by 3.5% this year. How many more kids are enrolled in elementary schools this year if there were 42,500 elementary school enrollments last year? And here the amount of increase in enrollment is 3.5% of the enrollment last year. And so for an algebraic solution, we have A representing the amount of increase in enrollment this year, unit 1. A becomes equal to 3.5% of enrollment last year. And that comes to 1,488. So there were 1,488 additional elementary school enrollments this year. Okay, the fourth kinds of problems that we look at are those that are similar to grand total problems. So we have a piece, and then we want to add it to the initial amount to find the total after increase. Problem 10. The population of a town increased by 5.7% over the past 10 years. What is the population today if the population was 142,000 10 years ago? Now the key sentence here is that the population today is 105.7% of the initial population, because of the fact that we have an increase. This is similar to 113% in computing the grand total when there is 13% tax. So the 100% represents the initial amount, and the 5.7% represents the additional amount. For an algebraic solution, we write down with A being the population today, unit 1. A becomes equal to, now we have to explain where 105.7% comes from. So 100% plus 5.7% of the initial population, 142,000. And A becomes 1 plus 0.057, 105.7% of 142,000. So the population today is 150,094. Problem 11. Price of goods, that should be goods, increased by 2.4% this year. What is the price of a laptop that cost $750.99 last year? Now, with the previous problem that was similar to this, we were trying to find the amount of increase, but now we want to find the new price, which is the initial price plus the increase. So that signals that we have to go with 102.4%. Key sentence: price today is 102.4% of the price last year. For an algebraic solution, with P representing the price of the laptop today in dollars, P becomes equal to 1, that's 100%, plus 0.024, which is 2.4% of the price of the laptop last year. So 1.024, which is 102.4% of the price of the laptop last year. And so this year I will have to pay $769.01. All right, so now I think we have one more problem in this category. Yes, we do. Okay, elementary school enrollment increased by 3.5% this year. How many kids are enrolled in elementary schools this year if there were 42,500 elementary school enrollments last year? Now again, with the previous problem that was similar to this, we were looking for how many more kids are enrolled in elementary schools. So the amount of increase, which is similar to the amount of tax problems. And for that reason, we used 3.5%. But now we are trying to find how many kids in total are enrolled in elementary schools. So that's the initial amount plus the increase. So that signals that we should go with 103.5%. key statement. Enrollment this year is 103.5% of enrollment last year. And now with A representing enrollment this year, Unit 1, A becomes equal to 103.5% of enrollment last year, 42,500. So 103.5% of the enrollment last year. So this year we had 43,988 elementary school enrollments. All right, now we could of course chain these very similar to money problems where we had now discount followed by tax. Now we can have a similar situation. Okay, let's take a look at the first problem of chain direct proportion type. And this one says that the population of a town increased by 3.8% in the 1990s and increased again by 7.2% in the 2000s. What is the population now if it was 251,000 at the beginning of the 1990s? So we have a problem where we want to find two grand totals. First, the population at the end of 1990s, so the grand total at that time, and then the population at the end of 2000s. So that would be another grand total. We will be using 103.8% to find the population at the end of 1990s, and then we will use 107.2% to find the population at the end of 2000s. In both cases we are adding 100% because we are looking for at an increase and we want to find the total after. For an algebraic solution, now for chain proportion problems, it may be easier if you start with the initial amount and then decide what happens to it. So rather than going from left to right, it may be easier to set up the equation going from right back left. With n being the population today, Unit 1, I start with the population 251,000. This is the initial population. Now, I'm leaving a bit of white space on the left side in anticipation that I will be working by 100% plus 3.8% and then 100% plus 7.2%. So this is the population at the beginning of 1990s, and if we find 103.8% of that, then we have found the population at the end of 1990s, which is the population at the beginning of the 2000s. And then we multiply this by 107.2% to find the population at the end of the 2000s. That's equal to the population today. So the population today becomes, now if you want to read it from left right, you can do that as well. And by the way, chain multiplication can be decoded in both directions. You can go from left to right. This is something I will talk about in a future video. You can actually decode this from going from left to right and look at the sub-expression 1.072 and 1.038. In effect, if you go from left to right and do your multiplications, you'll find the equivalent percentage in increase in population from the beginning of 1990s to the end of 2000s. You can also decode going from right left. Factor by factor, you're finding this is the initial population at the beginning of 1990s. Then when you multiply by 103.8%, you find the population at the end of 1990s. And if you multiply that by 107.2%, you'll find the population at the end of 2000s. And the grand total comes to 279,297. So the population today is 279,297. Now in this case, we had a situation where we were looking for two grand totals in a row. Here's another problem where we're not looking for two grand totals in a row. This one says in a sample of 4,500 frogs, 15.8% have red eyes. Of those that have red eyes, now this is a signal that I'm going to be using 15.8% because I'm looking for those that have red eyes, and 15.8% have red eyes. 82% have green skin. How many non-green skinned? Now that signals that I'm going to be using 100% minus 82%, because 82% refers to those that have green skin, but I'm looking for those that don't. How many non-green skinned red-eyed frogs are there? So you see the two conditions that I'm looking at, this is in the question part. in the interrogative or imperative statement that comes. I'm looking for non-green skinned red-eyed frogs. For non-green skinned, I will use 100% minus 82% because 82% is for green skinned. For red-eyed, I will use 15.8% because that's the percentage for red-eyed frogs. Alright, so with n representing the number of non-green skinned red-eyed frogs in the sample, unit 1, we start with the initial number of frogs, which is 4,500, and then we find 15.8% of that. This will give us the number of red-eyed frogs in the sample. 15.8% of the total number of frogs. And once I have the number of red-eyed frogs, then I will multiply this by 100% minus 82%, the percentage that represents the non-green skinned red-eyed frogs, and that becomes equal to the number that I'm looking for, the number of non-green skinned red-eyed frogs in the sample. So n becomes equal to 18% of 15.8% of 4,500, and that comes to 128. So there are 128 non-green skinned red-eyed frogs in the sample. Alright, and I believe this is the last problem. 62.5% of the eligible voters voted. Of those who did not vote, shame on them, 34.7% cited long work hours as the reason for not voting. How many eligible voters who did not vote cited reasons other than long work hours as the reason for not voting? There are 738 eligible voters. Okay, so it says, let's take a look at whether we'll be using 62.5%, 100% minus it, or 100% plus it. It says 62.5% of the eligible voters voted. Now we say of those who did not vote. And if you also take a look at the question part, it says how many eligible voters who did not vote. This is the key statement you should look at. Take a look at what you're looking for, what it is that you want to find, and then compare that to the percentage and see what that percentage refers to. How many eligible voters who did not vote? 62.5% voted, and therefore we will be using 100% minus 62.5%. That's the percentage that goes with those who did not vote. Next, we have 34.7% cited long work hours as the reason for not voting. But what we are trying to calculate is those who cited reasons other than long work hours as the reason for not voting. So we will be using 100% minus 34.7%. For an algebraic solution with n representing the number of eligible voters who did not vote and cited reasons other than long work hours as the reason for not voting, unit 1. We start with the total number of eligible voters, and now we find 100% minus 62.5% of them. That represents the number that did not vote. And because 34.7% cited long work hours as the reason for not voting, and we are looking for those who didn't cite this particular reason, we multiply by 100% minus 34.7%. So we end up with 65.3% of 37.5% of 738, which is 181. And therefore, 181 eligible voters who did not vote cited a reason other than long work hours as the reason for not voting. Alright everyone, so this brings us to the end of general percent problems. Now, I will be making one more video with more on money problems. There are some very interesting aspects of these equations and kinds of problems that fall into sub expressions of these equations, sub expressions of the expressions that you see, like this one. So for example, if we take these two brackets and ignore the 738 and we multiply them, what kind of information we get from that? And it's actually a very interesting piece of information that we get, including what happens if we switch the brackets, and some other very, very interesting topics will come your way in the next video. Thank you so much for watching this one, and I will see you in the next video.